Hello everyone, welcome to Ascend the Pathway of Success, and this is Abhijyotishan. Welcome to my channel. And as I told that I will bring the next chapter on the the second chapter of chemistry, that is the acids, bases and salt, as we have completed all the first chapters of the three portions, physics, chemistry and biology. So today we will gonna cover the chapter named acid, bases and salt. So this chapter is nothing but the definitions or understanding of acids, bases and salt. This chapter is all about acid, bases and salt. We will learn what is acid, okay, what is the importance of acid, what is base, and what is salt, how salt is formed, okay, and how many types of salts are there. In the last portion of this chapter we will learn that, okay. So today's chapter is acids, bases and salts. Okay, we all know that there is a certain substance known acid and another substance base. What is the basic differences between these two words, acids and bases? What are these two basic differences? Acids, bases. This is sour in taste, and base is bitter in taste. Between the tastes, the first difference states that what substance is in acidic medium and what substance is in basic medium, okay. So the first point is sour in taste and it is bitter in, and the next difference is about the change, okay, the change of the litmus paper. We all know that litmus is a indicator. We will also learn what is the indicator in the next portion of this chapter, okay. Turns blue litmus into red. In the same way, turns red litmus into turns red litmus into blue color, okay. What if we put blue litmus into bases, as it already turns red litmus into blue, so the nothing will be changed in the in the same way. If we put red litmus in acid also, it will not change its color, okay. We will dip the blue litmus into acids, the color of that portion will change into red color, and in the same way if we touch that into a basic solution, red litmus will turn into blue color, okay. So the next thing is what is acid? This simple definition of acid, okay. What is acid? Acid is a substance which contains more H plus or H3O plus ions, okay. So the solution or the compound which contains H plus or H3O plus ions, okay. So just like the example is, we all know one of the example is HCl, that is hydrochloric acid. How it is forming H plus ions? If we divide this hydrogen and chlorine, H plus Cl minus. This we have read in class 9 how to do this. Okay, we have divided HCl into hydrogen and chlorine, H plus Cl minus. So it is forming H plus ions. H plus ions. So it is acid. Okay. So the next one which we will do is base. A solution which contains OH minus ions. In acid we have seen that the solution should contain H plus ions, and in base the solution should contain OH minus ions. Okay, the solution which contains OH minus ions in its compounds is known as bases. Example: NaOH, sodium hydroxide. We all know the formula of sodium hydroxide is NaOH. If we divide this, Na plus OH minus. Is it forming OH minus ions? Yes, it is forming OH minus ions, OH minus ions. So it is a base, NaOH. Okay. Now we will see some naturally occurring acids. Okay, some naturally occurring acids. Nettle Sting. I will not give many. Okay, let me see how much are there in your book, in NCERT book. Okay, Nettle Sting, vinegar, orange. This all contains acid. Okay, turmeric, tomato, sour milk, that is curd, lemon, and sting. Okay, nettle sting, methanoic acid. Methanoic acid, vinegar, acetic acid, orange, sorry, that's not in orange, it is citric acid, turmeric, tartaric acid, tomato, oxalic acid, sour milk or curd, it is lactic acid. Okay, you have to remember these things. Okay, this chart, this can come in two ways. Methanoic acid is present in which thing? You have to write nettle sting or and sting. Okay, it will be also methanoic acid. Mn is also citric acid. Okay, it is citric acid. I know the handwriting is worse. Okay, this can come in two ways. Methanoic acid is present in which things? You have to write Nettle Sting or and sting, or you can write both and. Okay, Nettle Sting and sting. Now it can also come in this way. Which acid is present in Nettle Sting or ant sting? Which acid is present in Nettle Sting or ant sting? Then you have to write that is methanoic acid is present. Okay, so the next portion is strong acid, weak acid, strong base and weak base. Strong acid is that which contains more H plus ions, and weak acid is that which contains less H plus ions. And strong base is which contains more OH minus ions, and weak base is that which contains less OH minus ions. Okay, so HCl, that is hydrochloric acid, sulfuric acid H2SO4, HNO3, that is citric acid. These three are strong acid. Please note down in your copy. And H2NO3 carbonic acid, H2PO4 that is phosphoric acid. These two are weak acid. And in base section, NaOH, that is sodium hydroxide, potassium hydroxide and calcium hydroxide are strong bases, and magnesium hydroxide is weak base. That is magnesium hydroxide contains less OH minus ions. This 3 contains more H plus ions, OH minus ions, and in the acid section this 3 contains more H plus ions and this 2 contains less H. Okay, so we will see now what are alkalis. What are alkalis? All bases do not dissolve in water. The substance which dissolves in water and the nature should be the base. In simple words, we can say that a base which is dissolved, which get dissolves in water, those types of bases are known as alkalis. The bases which gets dissolved in water is known as alkalis. They are soapy to touch, they are bitter in taste and they may cause harm to the human body. Okay, that means let us take an example of an alkali, a soap. Soap is a soapy in touch, that are bitter in taste. Yeah, how we will get to know that it is bitter in taste, but yeah, it is bitter in taste. And also it causes harm. It is harmful for our health if we consume that. So that's why only we are handling any child safely if any soap is if any soap is located behind that child. Okay, so if by mistake that child consumes that soap, that will cause harm. This is soapy to touch. This is bitter in taste. The third point is this is harmful if it is consumed by the human body. Okay. Now the next one. What happens when acid is added with any basic substance? Acid plus base a salt will be released. Okay, a salt will be formed. Acid plus base equals to salt plus water. Okay, and this reaction is known as neutralization reaction, because acid and bases both are involved in a reaction, and the salt which will be resulted, that will be neutralized in nature. Okay, that will be neutral in nature. So it is known as neutralization reaction. Okay, now we will face some factors of this chapter. Okay, what happens when acid is added with metal, or metal is added with any acid? Okay, usually we used to add metal into acid, not acid into metal. Okay, both are different. Acid plus metal, salt will be released, a salt will be formed, plus hydrogen gas will be evolved. In the same way, in the basic, if acid is added to any base, that will result the same, salt will be formed plus hydrogen. Example, let us see example. HCl, that is hydrochloric acid, plus Zn, that is zinc. HCl acid plus metal, zinc chloride, ZnCl2 plus H2. HCl plus Zn, that is ZnCl2 plus H2. It is also a combination reaction, decomposition reaction, but it will be base plus metal. Base NaOH, that is sodium hydroxide. We all know that sodium hydroxide is a base, plus Zn, it is a metal. What is forming? Na2ZnO2, that is sodium zincate. Okay, remember the name of the formulas. ZnO2, Na2ZnO2. Okay, plus hydrogen gas is evolving. Okay, so what is salt over here? Which is salt? Sodium zincate. Okay, now the next one is the next one which we are gonna do is what happens when acid is added to a metal oxide. Not acid is added to a metal, but metal oxide. Acid plus metal oxide, it is forming salt plus water. Salt plus water. Acid plus metal oxide forming salt plus water. Why it is becoming water? Because we know metal oxide means, suppose ZnO, calcium oxide CaO. So one oxygen is added in this reaction. So what will happen? In this case only hydrogen was there. Hydrogen plus O, that is H2 plus O2. What is happening? What is forming? Water. H2O, water. Okay, you have to think about this. You have to relate with the base of the of anything. If you are getting relation with the base, then only you will be getting the depth of these reactions. Okay, so the next point which we are gonna see is some specific or important points which we have to remember throughout this whole chapter. Okay, so most metal compounds should have something, what will be their nature. Okay, so most acidic compounds are basic in nature. Most acidic compounds are basic in nature. The same way most metal compounds, not acidic compounds. I have actually mixed the another theory of chemistry. Okay, most metal compounds is connected. Most metal compounds are basic in nature. Most non-metal compounds are acidic in nature. Most non-metal compounds are acidic in nature. So the next one is most concentrated solution we know. Okay, we have heard most concentrated solutions, diluted solutions. What does that concentrated and diluted means? Concentrated means no water is added or no water is mixed. No water is mixed. And what do you mean by diluted? That is, water is mixed. Sometimes we use acid also in diluted way. Okay, because maybe we can't use that raw acid in some purpose, because that can explode. Okay, and you know, in a laboratory explosion can be very harmful. Okay, so in that case we have to change that raw acid or raw solution into the diluted solution. Okay, so in that case we doesn't add water to acid. That is, suppose in a beaker acid is there. Okay, we do not add water in the acid solution. That can explode, because H plus ions will increase in the high amount and heat will be generated, explosion can cause. Okay, what we have to do? We have to add acid into water. Okay, suppose it's a straw or a pipe, beaker. It is we have to take first amount of water which we have to add. Water is there and we have to add acid by drop. Okay, not together, drop by drop. We have to put acid into this water containing beaker and in these same way simultaneously we have to do like this way with the straw, so that acidic or H plus ions doesn't concentrate it in a position. Okay, so these are the things which you should know or you should remember while performing an experiment. Okay, so the next one is water indicators. Water indicators, the chemical substances which help us to detect any substance's nature. Okay, how do we knew that soap is basic in nature? Why would that soap is acidic in nature? How we came to know? By putting or by testing it with indicator, we come to know that soap is basic in nature. Suppose one example is litmus paper. Litmus paper is one type of indicator. Indicators are the chemicals which help us to detect the substances nature. Example, litmus paper. Okay, indicators are the chemicals which help us to detect the substances nature. Okay, this is very simple. The next one is what are olfactory indicators. What are olfactory indicators? What are these? What type of indicators are these? Olfactory indicators are the indicators. What happened? Olfactory indicators are the indicators which detect the nature of the substances by their odor, by change in their odor. Okay, normal indicators, how the litmus paper tells us. Okay, it simply changes into color. Blue litmus changes into red color changes into blue color. But no, in this type of indicators, olfactory indicators, by name only we are going to understand all, that is odor. Okay, odor gonna define us what is the nature of that substance. Okay, these are the indicators which detect the nature of the substance by change in their odor. Okay. One example is there are so many examples. Vanilla essence, onion clove. Okay, vanilla essence, onion clove. Okay, vanilla essence and onion cloves. These are the indicators which detect the nature of the substance by change in their odor. Okay, by change in their odor. So simply just remember the names carefully. Olfactory indicators, odor. Okay. Okay. The next one is universal indicators. Universal indicators. Okay. Okay. What are universal indicators? What type of indicators are this? Universal indicators are the indicators which not only detect the nature of the substance but also detect their medium. Okay. Suppose pH range. Okay, I will just make a diagram in the next slide. Okay. These are the indicators which not only detect the nature of the substance, but also state their acidic or basic medium. Acidic or basic medium simply means that how much acidic it is, that is weak acid, strong acid, how much basic it is, strong base, weak base. Okay. So the example is pH paper. Okay. What type of pH paper? What is a pH paper? pH paper contains numbers. Okay, from 0 to 40. Okay. There should be 14 gaps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. 0, 1, 2. Okay. Not from 0. In pH paper we count from 1. 0 is universal. Okay, 0 is universal. In the paper we doesn't count 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How does it looks? The colors are there in your book. Just 1 minute. This is the pH from red to purple. Okay. Red, orange, yellow, green, blue, purple. What does this mean? That is 1. Let us add 0 also. Yeah, in paper you will not get 0, but as the educational purpose, in your book 0 will be given, but in the practical side you will not get 0. Okay, so now you are only in class 10, so let's do this. Let's include 0 also. Okay, 0 means very acidic. Okay, if this solution changes its colors into purple, uh, red, purple, green. Okay, so if if the color of the solution changes into red, that means it is very acidic. Okay, so 0, 1, 2, 3, this is very acidic. Okay, slightly it is changing its. Okay, 0 is the topmost level and 14 is the topmost basic level, that is very basic. Suppose 12 to 13, 12, 13, 14, very basic. 8, 9, 10, 11, basic. 3 to 6, acidic. Not very acidic, not very basic. And what is this 7? Okay, in the number 6 and 8 also, it's type of neutral, but still if you want to count the minute things, then you will find that 6, that is, it comes under the acidic portion. Okay, and the 8 comes under the basic portion, so it is neutral. Okay, it is neutral. 7 means neutral, which is green in color, red in color, and it is violet in color. In the in your color sets also, when we buy the new set of 25 shades of color, then there you can find that colors are arranged in that way. Okay, red, orange, yellow, green, then deep green, Prussian blue. Okay, okay. Now, importance of pH in our everyday life. Importance of pH in our everyday life. Okay. Our body works within the pH range of 7.0 to 7.8. As I have told that blood is neutral in nature, that is 7. So our body automatically works within the pH range of 7.0 to 7.8. Okay, it is not basic. It is neither basic nor acid. Okay, our body works within the pH range of 7.0 to 7.8. It is number 1. Roman 2. Living organism can only survive in the narrow range of pH change. Okay, suppose acidity. Okay, maybe 7.0 or 7.8 turns into 5 or 6 during acidity. Okay, if that changes in up to 3 or 4 or 2, in that case it will not be possible for a human being to survive. Or in the same case, in the basic side also, if it changes into a very basic very range, it will not be possible for a human being to survive. Okay, human beings survive only in a narrow change in a narrow pH change. Okay. Roman 3. What is the pH of rainwater? We know, acidic rainwater, acid rain. We all know. We have read it in class 6 most probably in CBSE, and in ICSE most probably in class 4 to 5 they have already read what is acid rain. pH of acid rain 5. Okay, 5 to 5.6, 5.0 to 5.6. Acid rain, pH of acid rain ranges between 5.0 to 5.6. Okay. Roman 4. Tooth decay below in the pH change when our tooth pH of our tooth comes lower than the 5.5, then the tooth decay starts. That is, it becomes acids and our teeth slowly turns into, or what to say, turns into a bad health. Okay. Tooth decay starts when pH changes lower than 5.5. Lower than 5.5 means it's acidic, and that's why only we in every morning we brush our teeth with the toothpaste, and toothpaste is basic in nature. Why we use a basic substance to brush our teeth? So that the germs which are formed, or the acid which are formed in our teeth, those gets neutralized when we add that basic, or when that basic in touch with our teeth. Okay, the neutralization reactions occurs and it turns the acidic medium into neutralization reaction. Okay. So the next one is, now we will see what are the factors of the chemical equations or the reactions states the nature of the salt which is formed. Okay. Strong acid plus strong base, neutral salt will be formed. Strong acid plus strong base, neutral salt will be formed. Okay, the pH or the nature of the salt will be neutral if strong acid is added with strong base. Now what happens when strong acid is added with weak base? Then it will go in the strong's favor, that is, acidic salt will be formed. In the same way, if weak acid is added with strong base, basic salt will be formed. Okay. Okay. So there are 5 types of salt. 5 types of salt. First salt is common salt, that is NaCl, sodium chloride, common salt which we use. Okay. The next one is bleaching powder. Bleaching powder, it is also a salt. What is it? CaOCl2. CaOCl2. Doesn't it have a chemical name? Yes, it has. It have both. Calcium oxychloride. Calcium oxychloride. Okay. Now the baking soda. Baking soda. NaHCO3. NaHCO3. What is this? Sodium bicarbonate. Sodium bicarbonate. The next one is washing soda. Washing soda is Na2CO3, that is sodium chloride dot 10H2O, that is dot 10H2O. What does this dot 10H2O means? That it is present in crystal formation. Okay, any crystal equation or the case crystal compound contains this dot, half H2O, 5H2O, 3H2O, 10H2O. Okay, so it is its name is sodium carbonate decahydrogen. Sodium carbonate decahydrogen. Hydrogen. And the last one is POP, plaster of Paris. We are very familiar with this, Plaster of Paris is CaSO4 dot half H2O. CaSO4 dot half H2O. Copper sulfate crystals. Okay, it is copper sulfate hemihydrate. Copper sulfate hemihydrate. Okay, now we will see how those salts are produced. How all those salts are produced. Bleaching powder. CaOCl2, calcium oxychloride. How that is formed? CaOH whole 2, you all know, calcium hydroxide plus chlorine. That is, calcium hydroxide is reacted with chlorine, then it forms. Then bleaching powder is formed. CaOCl2 plus H2O, water, calcium oxychloride, and this is bleaching powder. This is bleaching powder. Okay. So the next one is baking soda. Baking soda. NH3, that is ammonia. NH3 plus NH4Cl2, that is ammonium chloride. NH3 plus NH4Cl2 is forming NaHCO3. That is baking soda. This is baking soda. Okay. Now the washing soda. Washing soda, Na2CO3 plus 10H2O. It is very simple. Sodium carbonate plus water molecules. Na2CO3 plus 10H2O is forming Na2CO3 dot 10H2O. Okay, Na2CO3 plus 10H2O forming Na2CO3 dot 10H2O. Okay. Now plaster of Paris, POP. Okay, on hitting gypsum at 373 Kelvin, it loses water molecules and becomes becomes calcium sulfate hemihydrate. Okay, a gypsum is a material. Gypsum is heated at 373 Kelvin. It loses water molecules and it forms calcium sulfate hemihydrate. On heating gypsum at 373 Kelvin, it loses water and forms CaSO4 dot half H2O. Okay. Okay, now how to retake its reaction. Okay, how to form gypsum again from CaSO4 dot half H2O. That means plaster of Paris. Okay, to reform for reforming gypsum, we have to add CaSO4 dot half H2O. We have to add with 1.5 H2O. What does that form? Half plus 1.5, that is 2. CaSO4 dot 2 H2O. Gypsum. Again gypsum is formed. Okay. So here we go with the end of this chapter, that is acid, bases and salt. Hope you all have liked this video. Hope you all have understood this video, and I am repeating again, if you can't understand any of the portion of this chapter, please let me know in the comment section. Please don't hesitate to inform me. I will surely make a separate video on that specific matter or that specific topic where you guys have problem. I will try my hardcore best to make you all people understand and score good marks in your exam. Thank you for being with me for such a long time, and I will bring the next video on the second chapter of biology, that is the first chapter was life processes. So our next chapter will be control and coordination. Our next chapter will be control and coordination, serial wise chapter number 2 for the biology portion of class 10 NCERT book. Okay, till that, take care, goodbye.